So the Chapter 8 test is going to have 13 questions on it. Of those 13 questions, one will be a proof. Now you will have real world examples. The real world examples, like that lakefront question that you had in the homework, the numbers are not going to be that large. I did reduce the numbers so they're not that big. You will not have any sometimes, always, or nevers. You will not have true, false. You're not going to have to write out a definition or anything, but be able to apply all of the definitions and the theorems that we learned in this chapter.
Is there only going to be one real world?
So most of the questions are going to be calculations or writing a similarity statement, very similar to what you saw in the quiz, where I give you pictures of two triangles and I ask you, are these triangles similar? And if they are, which theorem did you use? Did you use angle, angle, side, 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 or side, angle, side? And then it'll ask you to write a similarity statement. So as I go through each one of the lessons, I'll talk about the different vocabulary that you're going to see. So let's go ahead and take a look. Okay, so this is the first page. Now, what's nice about this chapter review is the beginning or the top part of each section. It has a nice little explanation or a nice little review of what you covered in that section. So in section 8.1, this is where we learned what a similarity statement was. So this right here is an example of a similarity statement. So that is the similarity statement. So if they ever ask you to write that, that's what they're expecting you to have, is all of the vertices with the symbol of a similar, which is like that little wave in between, and then the vertices of the second figure that it's similar to. Then the next thing is, and you had to do this on the quiz, it was the first question. They're also asking us to list all the pairs of congruent angles. So when you're given a similarity statement, finding all of these pairs of congruent angles is easy because all you have to do is look at your similarity statement and you can see that the first letter E matches with K, and that's what they wrote here. And then H was the second, and it matches with L. And then the G, the third letter, matches with the M, the third letter there. And then lastly, the F and the N. So this makes it easy to find the corresponding angle pairs. Remember, when two figures are similar, the angles are always congruent. However, the sides are proportional. Now, if it ever asks you, and it did ask you on the quiz, to write all of the corresponding side lengths in a statement of proportionality, this is where you're going to match all of the corresponding sides, and you can use the similarity statement to help you, but this right here is the statement of proportionality, where you would match the corresponding sides. And again, if you want to use the similarity statement to help you, do that. So for example, the first two letters here, KL, in the statement are going to match with EH. And that's what was put right here in this statement of proportionality. The order that you put those fractions in there, or those ratios, it doesn't matter. Then the next fraction was the LM, which was the second and the third letter. So here's second and third letter. So LM matched with the HG. And so on. So this is your statement of proportionality. You did that on the quiz as well. So now questions number 1 and 2 in the homework here, they want you to answer all of these questions. So for the first one, it wants us to find the scale factor. It wants us to list all the pairs of congruent angles. And it also wants us to write the ratios of the corresponding side lengths in a statement of proportionality. So this statement of proportionality, this was this. So I'm going to do the same thing here. I can use my similarity statement to help me. So I could match AB, the first two letters, with EF, the first two letters there. So AB and EF. Notice this was turned, so it's not sitting in the same orientation. So we would write EF over AB. And again, it doesn't matter where you start. If I decide to do the next two letters, the BC and the FG is here, BC is here. So again, I would put FG over BC. Now I'm also looking for a scale factor here. The only way I can find a scale factor is putting it into the ratio of the corresponding sides. So far all of my matches didn't have a number on both of the corresponding sides. So let me keep going here. If I take C and D and match it with the last two GH, GH is 9. Oh, I finally found a pair of corresponding sides that actually have numbers. So this I could put together. So GH over CD. And then this would have been 9 over 12. And then I can reduce that by dividing them both by 3. And it reduces to 3 to 4. Now, this 3 4, so 3 to 4, this is the scale factor. This is also known as the ratio of the corresponding sides. These both mean the same thing. And then I have to match one last side here, and that could have been the beginning to the end, the AD to the EH. So AD and then EH. EH had a number, but AD didn't. But I can still put it in my statement of proportionality. So EH and then the AD. So this would be my statement of proportionality that I'm boxing in purple. This is my scale factor that I'm boxing in red. And then it also wanted me to list all the congruent angle pairs. And this is where I can use my similarity statement. So I could match the first letter, A and E. So A is congruent to E. Then B, the second letter, is congruent to F. The third letter, C, is congruent to G. And then D is congruent to H. So these would be all of the congruent angles. 2, same thing. We need to find the scale factor. We need to find the statement of proportionality. And we also need to list all of the congruent angle pairs. So if I want to do the angle pairs first, I could do X and R. So angle X, congruent to angle R. Y is the second letter. So angle Y, congruent to angle P. And then Z to Q. So angle Z, congruent to angle Q. These are all the congruent angle pairs. Now again, I can use this statement of proportionality, or the similarity statement, to write my statement of proportionality. So XY, the first two letters, are going to match with RP. So XY is right here, and RP is 10. So again, for my statement of proportionality, I can do RP over XY, but for my scale factor, I can go ahead and take the 10 over 25, reduce it, divide them both by 5, and it's 2/5. Now we're going to actually see that all three sides, no matter which one I chose, they're all going to simplify to 2 over 5. So if I take the next two letters, the Y and the Z, and the P and the Q, PQ is here, and then YZ is here. So if I put PQ and then YZ, and again, if I test out this fraction, I can divide them both by 3, and it also simplifies 2 to 5. And then the last one, I could go from the beginning to the end, so X to Z, and then R to Q. So that would have been XZ is 20, RQ is 8. So if I do 8 over 20, divide them both by 4, 2 to 5, and this would be my last ratio that I would put in my statement of proportionality. And again, the order here doesn't matter. If you would have preferred to write the purple fraction first, and then the blue, and then the red, it doesn't matter. So again, this is the statement of proportionality. This is your scale factor. which is also your side length ratio. So those all are the same thing. And your similarity statement is this from the beginning. Now, you're not always given a similarity statement. So if you're not given one, then we would have matched the smallest number with the other smallest number. And that's how we could have found out the correct corresponding sides. Now, if we were asked what we would have used to show that these are similar, because we were able to match all three sides and they simplified to the same ratio, the theorem we would have used would have been side, side, side here. Now, we hadn't officially learned side, side, side yet. That didn't come up until 8.3. But again, because the test is on all 4 lessons, you can use it at any point in the test. Now, for number 3, we already talked about the scale factor being the same thing as the ratio of the scale of the sides. So we're going to use that information for number 3. So they're telling us that the 2 triangles are similar. And for number 3, they tell us it has a scale factor of 3 to 5. And again, I could write it as a fraction. They want us to find a missing altitude. So in order to find any missing corresponding part of a triangle, whether it's an altitude or a median, I can use the scale factor. So they gave me the length of the larger triangle's altitude, and they said it was 24 inches. So I'm going to use this scale factor, and the place that I'm going to put the 24 is going to be across from the larger number in my scale factor, because the 24 was for the larger triangle. If it said the 24 was from the smaller triangle, then I would have put it next to the 3. So now that I've placed it in my proportion, now I can do the cross products. So I'm going to be multiplying diagonally 5 times x, 3 times 24. I end up with 5x equals 3 times 24. 3 times 24 is going to give me 72. I'm going to divide both sides by 5. So 72 divided by 5 goes in here once. Subtract 4. Now, if you're writing it as a mixed number, it would be 14 and 2/5. If you decided to make it a decimal, you would add a decimal point and a 0, bring down the 0, bring up the point, and then 5 goes into 24 times. So this is also 14.4, and they gave us the original information in inches. So again, to find any missing piece, you can use the scale factor. Now for number 4, this is the information we used, the 2 theorems in 8.1. The first one was for the perimeters, and in addition to the scale factor being equal to the side length ratios, it's also, so this is, the scale factor is equal to the ratio of the corresponding sides, and the theorem also told us that the scale factor is also equal to the ratio of the perimeters. This was the theorem that we learned in 8.1. So scale factor, ratio of the corresponding sides, ratio of the perimeters is always the same number. However, whenever it's the scale factor squared, that's going to be equal to the ratio of the areas. So the areas ratio. And this was the question on the quiz that a lot of people missed because you forgot to square the scale factor. So let's go ahead and try number 4, because we're going to use this and this to answer number 4. So for number 4, they're telling us that we have similar triangles with corresponding side lengths of 12 and 8 meters. So the corresponding ratio, or the scale factor ratio, would be 12 to 8. I can divide them both by 4, and this simplifies 3 to 2. This 3 to 2 is my scale factor. It's also my side length ratio, my perimeter ratio. So for number 4, I'm going to take this scale factor of 3 to 2, and I'm going to set it equal to, first for the perimeter of the larger triangle is 48 meters. So I need to put the 48 across from the larger number in my scale factor, and then my unknown smaller triangle perimeter is the variable in the denominator. Cross multiply. I can multiply that and get 96, and then I have to divide by 3, and I get x equals 32, and these were meters. Now, another shortcut at this step right here, if you don't want to multiply 2 times 48, if 3 will be divisible into one of them, you can do that. I can divide one of these by 3, and now I'm just left with multiplying 2 times 16, and that gives me my answer. So you could solve this either way, since we're not using a calculator. Now for the area portion of this question, we have to take the scale factor. So now for the area part, I'm going to take my scale factor and square it. So this is going to give me 9 over 4. And then the area that they gave me for the larger one is 180 square meters. So again, I put it across from the larger number, and then the smaller area is at the denominator. So again, I'm going to cross multiply 180 times 4. If I want to go ahead and multiply that, I get 720. Divide by 9, and x equals 80 square meters. Now, if you didn't want to multiply this, you could have left it like this, and then when you divide by 9, that cancels, and then I could have simplified 9 divided by 9 is 1, 9 goes into 180 20 times, so then it's just x equals 80. A little simpler way to do calculations without a calculator. So that was number 4. Now, 5, 6, and 7, or 5 and 6 will be similar questions that you'll have on the test, just like you did on the quiz, where I give you 2 triangles and I ask you, are they similar? And if they are, which shortcut did you use? So for number 5, and I'm going to turn number 5 into a proof, just to show you a little preview of what you may see. So for number 5, let's turn it into a proof. And I'm also going to be able to come up with my similarity statement. So for number 5, I'm going to give you, so given that angle Q equals 35 degrees, angle T equals 35 degrees. I want you to prove that triangle RSQ is similar to triangle UST. Now, this question didn't ask you to write a proof. It just wanted you to say, yes, they're similar, and what reason, and then to give this statement. So this is the similarity statement. So let's go ahead and set up our proof. I just changed this problem to be a proof. So again, your picture here looks like this. And it had Q, R, S, T, U, 35, 35. Now, in order to prove 2 triangles are similar, you need to find either proportional sides or 2 congruent angle pairs. So I could actually find the one that was given. So Q and T are congruent. Now I need to actually state that in my proof. So let's go ahead and set up your statements and your reasons. So number 1, angle Q equals 35. Angle T equals 35. And this reason is given. Now, I need to show that they're congruent. So now my next statement is going to be angle Q congruent to angle T. And my reason is substitution or transitive, because what I did was I took out 35 and I replaced it with T. So substitution or transitive, I would accept either answer on this. Now, so far, I've only got one pair of congruent angles in my proof. I needed another one. And the obvious one, when it's the bow tie, is going to be this one in the middle, because these are vertical angles. Now, you can't just say angle S congruent to angle S, because I don't know which side you're talking about. So you need to name it with 3 letters. So I'm going to name that vertical angle, and I can name it either RSQ or QSR, either way. But I'm going to name it angle QSR is congruent to angle UST. S has to be the middle letter. So this is the vertical angles congruence theorem. And now that I have 2 congruent angle pairs in my picture, I can now state that RSQ triangle is similar to triangle UST. And that reason is angle. Now be aware that you might get a picture where it's inside of it, and then they might give you that the lines are parallel, and then you have to maybe use corresponding angles. So we did this a lot in the notes, so refer to the proof we did in the notes as well. So this was turning number 5 into a proof. So yes, they are similar. The theorem is angle, and your similarity statement is the triangle RSQ similar to UST. Let's go ahead and try number 6 now. I'm just going to go ahead and do the problem. I won't write it as a proof. So we want to figure out, are these 2 triangles on number 6 similar? Let me zoom in here. So in order to prove them similar, again, I would need to know something about the sides to see if they're proportional. Or in this case, I know nothing about the sides, so I'm going to check out angle. So in order to do this, I need to find missing angle B by doing 90 minus 60, and I get 30. Well, without doing any more calculations, I can already see that B and E are congruent, and then also the 2 right angles. If I would have gone ahead and found D first, I would have done 90 minus 30, and either way, I've got all 3 angle pairs marked as congruent. So because I could find at least 2, this is similar by angle, and my similarity statement is triangle ABC is similar to DEF. And again, the order is important. A was the 60 degree, and it matched with D, and that's why they're the first 2 letters. And then B and E, they both had 30, and then the C and the F were the 90. The next one is the classic shadow question. So it says that a cell phone tower, so if we have our tower here, and it's casting a shadow, which is 72 feet long, and then there's a tree right next to it, and it's casting also a shadow, and it said that its shadow is only 6 feet, and it's 27 feet tall. So what I need to do here is match the corresponding sides. So I could match the 2 shadows. So 6 over 72 simplifies 1 to 12. Then I'm going to take that 1 to 12 and I'm going to match the heights. So since I did right over left, when I go to set it up, I'm going to do 27 over x. I'm going to do the cross products. 12 times 27, 1 times x, and I get x is equal to 324 feet for the height of the cell tower. Top of the page, again, it's got that little explanation. So in order to show that two triangles are similar by using side, 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 we would need to match all the corresponding sides. And if you're not given a similarity statement, this is where you're going to find the smallest number and match it with the smallest number here. And notice they did that, and they got 7 to 3. Then they looked for the biggest side, and they matched 35 with 15, the biggest number here. And that also simplified 7 to 3. And then the middle number, which was the 28 and the 12, and it also simplified 7 to 3. So because all three sides simplified to the same ratio, you would have said, yes, these are similar, and the reason would have been side, side, side. And the similarity statement would have been ABC is similar to DEF. Now, if you're going to use side angle side, again, you're going to do the same thing. However, you need to find the included angle to be congruent. And in this picture, the included angle is the vertical. And again, match the smallest number of this triangle with the smallest number from here. So the smallest number here is 21, and it's going to match with the 14. So they did 14 over 21, 2 to 3. Then they went back and they matched the 20 and the 30, and it also simplified 2 to 3. So because the included angle and the sides forming that angle are proportional, you can say that those two triangles were similar using side angle side. Now, for questions 8 and 9, so again, we're going to try to use these. Again, on the test, it's not going to tell you use side, 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 or side angle side. You just need to know which one of the three you can use. So for this one, I can pull them apart if that helps. So I got the little blue one here, and then I'm going to compare it to the whole red one. So the blue one on the top. So if I pull the blue one off, this is the CBD. And this has 4 and 3.5. Then the whole red one, I can add to get the length of AC, 8 plus 4. And then to get the length of CE, I need to add 3.5 and 7 and get 10.5. Now notice they both have angle C in common. So if you were writing a proof, it would have been angle C congruent to angle C. But then now we would have had to show that these sides are proportional. So I'm going to match the 4 and the 12. And that'll simplify 1 to 3. And then I could match the 3.5 and the 10.5. I can multiply it by 10, which moves my decimal point. And now I'm simplifying 35 over 105. I can divide them both by 35, and it simplifies 1 to 3. So because my sides are proportional, and because I have the congruent included angle, I can say, yes, these two triangles are similar by side angle side, and my similarity statement could be triangle CBD is similar to triangle CAE. Again, the order doesn't matter. Just make sure everything matches appropriately. Then for number 9, for this one, again, I can pull it apart if that's easier to see. So the little blue one here compared to the whole red one. So for the little blue one, this is the RUQ, 9, 14, and 10. And then I have the whole big red one, the TSQ. And to get the length of TQ, I add 4.5 and 9, 13.5. This one was just the 15. And then to get SQ, add 7 and 14, and that one's 21. Now, I don't have a similarity statement, but again, I'm going to go by the size of the numbers. So I'm going to look for my smallest number here, which is the 9, and it's going to match with the smallest number here. So I need to simplify 9 over 13.5. I can times it by 10, so I'll move a decimal point. So it becomes 90 over 135. And then I can divide them both by 45. So it simplifies 2 to 3. Next, I can match the 14, the biggest number, 14, with 21. So 14 to 21. This one also simplifies 2 to 3. And then lastly, I could match the middle number, the 10 and the 15. And then 10 to 15 also simplifies 2 to 3. So my scale factor, my side length ratio is 2 to 3. Because all 3 side pairs simplified to 2 to 3, I could say, yes, these are similar. And I could use side, side, side. But if you also notice, they both shared angle Q. So we could also have said this one was side angle side. So sometimes there's more than one. So my similarity statement for number 9 could be triangle QUR is similar to triangle QTS. Again, if you would have rather started with R, you could have said RUQ and then STQ. Just make sure everything matches. The Q and the Q need to be congruent, the U and the T, and then lastly, the R and the S. They need to match. And then number 10, they're telling us that these 2 triangles are similar. You know, I sort of wrote over this one. If I can erase and see that number. Okay, so for number 10, I'm going to use my similarity statement. Okay, so let's go ahead and do number 10 down here. So I need to match the corresponding sides. I can use my similarity statement here. So I could match AB with DE. So AB is 6 and DE is 24. So 6 over 24 simplifies 1 to 4. And then for the next ratio, I can either do AC, which is 9, and match it with DF, or the easier one would be BC, the next 2 letters, with EF. So then I could take my 1 to 4 and then match 2x over 32. This will be the easier proportion to solve. So I'll cross multiply, divide by 8, and x equals 4. Next page. Here is 8-4. Okay, in 8.4, this is where we learned several different theorems. We learned the triangle proportionality theorem. We learned the converse of it. We learned the 3 parallel lines theorem. And then we also learned the triangle angle bisector theorem. So be able to apply all of these. Now, you will not have questions like number 11 and 12 where you have to prove that the lines are parallel. What you're going to get are questions like number 13 where you would have had to find the value of x. So for 11, if you ever see it on a standardized test, to prove that these are parallel, then you would have had to show that these sides were proportional. And you could either do top to bottom or left to right. If I do 10 over 20, then I'm going to do 16 over 28. So 10 over 20 simplifies to 1/2. And then 16 over 28, I could simplify this 8 to 14. Actually, I can divide it by 4. That'll be better. So 16 over 28, divide them by 4, 4 to 7. So because these are not equal, this would have been no, these lines are not parallel. So then over here, if I simplify this top to bottom, 13.5, 22.5, and then do the 12 over 20, I can divide these both by 4, so 3 to 5. I can move these both, and this will also simplify 3 to 5. So because they simplify to the same ratio, yes, AB is parallel to CD. But again, I'm not going to ask you to show. I will give you that they're parallel, and then you would have to solve for X. So that's what you're going to be doing in number 13. To find the length of YB, let's put a little X there. And again, I'm going to do top over bottom. So I'm going to do 7 over X, 15 over 24. I highly recommend that you simplify the 15 over 24. I can divide them both by 3, and I get 5/8. And now I'll cross multiply. So I get 5 times X, 7 times 8 is 56. Divide by 5, and 5 goes into 56. Let's see, 56, divide, 0, 6, 1. Goes in there 11 and 1/5, or 11.2. And then the next one, I can go ahead and these are the 3 parallel line theorem. Notice they're not marked as parallel, but because I have corresponding angles here that are congruent, I can tell that all 3 of these lines are parallel. So it divides, that transversal divides it proportionally. So AB I could put here as X. So then I could do X over 7, and then 6 over 4. I can reduce the 6 over 4, make it 3 over 2, and now cross multiply. So 2 times X, 3 times 7, divide by 2, and X equals 10.5, or 10.5. And then the last question here is using that triangle angle bisector theorem, which again, I can put an X here, and it's dividing it proportionally. So I could do this top over that bottom, and then think of the 4 over X. So 10 over 18, 4 over X. Or if you'd rather do 4 over 10, and then X over 18, you can set it up that way as well. It doesn't matter. You're going to get the same things either way. If I simplify the 10 over 18, then I get 5X equals 36. Divide by 5, and X equals 5 times 7 is 35. So you can either make it 7 and 1/5, or add a decimal point, bring it down, and then 7.2. So either way on these. So again, this was a nice review. I highly recommend that you go back through your warm-ups, your notes, all of that. Now let me show you the 3 questions on the 8.4 warm-up. All right. Then this was the warm-up. Again, applying those theorems you learned. This one, notice they're parallel. So you could do top over bottom. So 20 over 10, simplify it 2 to 1, and then put X over 6. So 1 times X, 2 times 6, X equals 12. Same thing here with the parallel lines. Notice the little arrows here indicating these are parallel. So do X over 12. When you do 18 over 16, simplify it 9 to 8 first. Once you cross multiply, you get 108. Divide by 8, and you get 13.5. And then the last one, because these are congruent, it was bisected, so you could do 17 over 10, y over 14. 10y equals 238, divide by 10, and y equals 23.8. So again, don't focus on the review. Go back, review everything you have. Turn some problems into proofs. Go back, look at the proof in the notes. Again, 13 questions. No homework official. You also have that other study guide.